Hello friends, today I am going to discuss oscillations. Now this is the new chapter we are going to start today. Oscillation is an important topic in engineering physics as well as basic physics. In our daily life we come across many examples such as oscillation of physical as well as simple pendulum, vibrations of spring, molecular vibration in solid materials, etc. In this lecture series, I try to cover some of these examples of oscillation in details and their equation of motions. We also discuss the damped and forced vibration. Now, before starting different examples, first let me introduce what is oscillation. Oscillation is a special type of periodic motion, and periodic motion is defined as a type of motion which repeats itself after certain period of time. For example, here the rotation of the earth around the sun. The earth rotates in anti-clockwise direction around the sun, as you can see. If you consider the starting point of the earth is at this point, then after 365 days the earth comes at this point, and then it repeats its motion again and again after 365 days. However, oscillations is defined as the to and fro motion of a particle about this mean position. This is the schematic diagram of oscillations. This is the mean position. The arrow indicates the direction of movement of the particle. Suppose the particle start from this position and move towards the right direction and reaches at this extreme position, and then it reverses its direction and goes to the left direction. From this position it again reverses its direction. So this is to and fro motion of the particle, and this is called the oscillations. Thus, it seems that there is difference between the periodic motion and oscillatory motion. If you see the rotation of the earth around the sun, which is an example of periodic motion, at this point the earth moves always in the tangential direction and always in the same direction. However, in oscillatory motion, at the mean position, the direction of motion of this particle changes. But if you see these 2 points, the direction of movement is same. Thus, after this time interval, the motion repeats. So, this one and this one. So, this is called the full oscillation. Thus, oscillatory motion is periodic motion. Now, let's see how to characterize a oscillatory motion. So, we can characterize the oscillatory motion by some parameters. For example, one is the time period of oscillation. Now, what is the definition of that? The time duration after which the oscillating particle process the same position moving along the same direction. So basically this is this one full oscillation. This is the time required for this one full oscillation is called the time period of oscillation. And the frequency of oscillation, the number of full oscillation made in 1 second is called the frequency of oscillation, and the formula is basically 1 by t. T is the time period of oscillation. Now these are different examples of oscillatory motion. One is the oscillation of this pendulum, vibration of spring, vibration of molecular bonds in solid materials. So today I am ending here In the next class, we will discuss the oscillation of pendulum. Okay, then simple harmonic motion, damped vibration, forced vibration. We will proceed one by one. Okay, thank you.